The coincidence behind a total solar eclipse. The rare geometry behind total solar eclipses. By Physics Explained. A total solar eclipse is one of the most dramatic sights in nature. In the middle of the day, the sky grows dark, the temperature drops, and the sun seems to disappear behind the moon. For a few minutes, only the sun's faint outer atmosphere, the corona, remains visible. This spectacle is possible because of an extraordinary astronomical coincidence. The sun is about 400 times wider than the moon, but it is also about 400 times farther away from Earth. If you're reading this, you're already my kind of audience. I write here on Substack, post companion videos on YouTube, and also share episodes through my podcast. Subscribing is the easiest way to support the work. And if you're able to pledge, it makes a real difference. Because these two ratios are nearly the same, the sun and the moon appear almost the same size in our sky. The sun has a diameter of roughly 1.4 million kilometers, while the moon is only about 3,500 kilometers wide. The sun is therefore approximately 400 times larger than the moon. But the sun is also much farther away. The moon is, on average, about 384,000 kilometers from Earth, while the sun is about 150 million kilometers away, again, a ratio close to 400. The result is a remarkable visual coincidence. The sun and the moon appear almost exactly the same size in our sky. During a total solar eclipse, the moon can therefore cover the sun's bright visible surface, while revealing the ghostly white corona of its outer atmosphere. No other rocky planet in our solar system experiences total solar eclipses quite like Earth. Mercury and Venus have no moons, while Mars's two tiny moons, Phobos and Deimos, are far too small to cover the sun completely. From the Martian surface, they produce only small, partial, or annular transits across the sun. Apparent size does not depend only on how large an object actually is. It also depends on how far away it is. A small object nearby can appear as large as a much bigger object far away. You can see this by holding your thumb in front of your face. Your thumb is obviously much smaller than a distant building, but from the right distance, it can completely cover the building from view. The same thing happens during a solar eclipse. The nearby moon, though much smaller than the sun, can cover the distant sun almost perfectly. The coincidence is not exact. The relationship is only approximate. Both Earth's orbit around the sun and the moon's orbit around Earth are slightly elliptical rather than perfectly circular. Their distances therefore change throughout the year. Sometimes the moon appears slightly larger than the sun. When the alignment is perfect, it completely blocks the bright surface of the sun, producing a total solar eclipse. At other times, the moon is farther from Earth and appears slightly smaller. It cannot completely cover the sun, leaving a bright ring around its edge. This is called an annular eclipse, often described as a ring of fire. This variation makes the coincidence even more interesting. The apparent sizes of the moon and sun are not permanently identical. They simply overlap closely enough that, under the right conditions, the moon can cover the sun with astonishing precision. A temporary moment in Earth's history. Total solar eclipses have not always looked the way they do today, and they will not continue forever. The moon is slowly moving away from Earth by a few centimeters each year. In the distant past, it appeared larger in the sky and would have covered the sun more completely. Far in the future, it will appear too small to block the sun entirely. Eventually, total solar eclipses will no longer occur. Only annular eclipses will remain. This means that humanity exists during a special period in the history of the Earth-Moon system. A period when the moon is at almost exactly the right distance to cover the sun while still revealing its delicate corona. Coincidence or something more? Scientifically, there is no known physical law requiring the moon and sun to have nearly identical apparent sizes. The moon did not form so that it could perfectly cover the sun. Its current apparent size is the result of the sizes, distances, orbital motions, and long-term evolution of the Earth, moon, and sun. It is therefore reasonable to call it a coincidence. But coincidence does not mean unimportant. This accidental alignment has had enormous scientific value. Total solar eclipses allow astronomers to observe the sun's corona, study its magnetic activity, and investigate how light behaves near massive objects. The famous 1919 Eclipse expedition, led by Arthur Eddington, provided early evidence supporting Einstein's general theory of relativity. During the eclipse, astronomers measured how the sun's gravity appeared to bend light from distant stars. Normally, that cannot be done because the sun's bright surface makes the daytime sky far too bright. The faint light from nearby stars is completely overwhelmed. During a total solar eclipse, the moon blocks the sun's bright visible disk. The surrounding sky becomes dark enough for stars near the sun to appear in photographs. Astronomers could then photograph the stars near the eclipsed sun. Photograph the same stars months later, when the sun was elsewhere in the sky. Compare their apparent positions. If the stars appeared slightly displaced during the eclipse, that would indicate that their light had been bent while passing through the sun's gravitational field. The moon's apparent size did not merely create a beautiful sight. It helped humanity test one of the deepest theories in physics. A cosmic accident worth appreciating. A total solar eclipse is not simply the sun being covered by the moon. It is the result of an unlikely arrangement of scale and distance. A moon roughly 400 times smaller than the sun sits roughly 400 times closer to Earth. For a brief moment, these enormous differences cancel each other out. The result is darkness in daylight, a glowing solar corona, and one of the clearest reminders that beauty in the universe does not always require a deeper plan. Sometimes the most breathtaking events arise from geometry, motion, time, and coincidence. We are lucky to see such rare cosmic events. So if a total eclipse ever passes near you, go. The moon is drifting away, and the fit has a shelf life. Somewhere in the far future, there's a final one. If you're reading this, you're already my kind of audience. I write here on Substack and post companion videos on YouTube, and also share episodes through my podcast. Subscribing is the easiest way to support the work. And if you're able to pledge, it makes a real difference.